In Module 1, we explore the historical roots of engineering, its role in social and economic development, the ethical duties of engineers, and the importance of communication and public trust. Now, we move into the present and future. We'll focus on the challenges and opportunities facing engineers today, and how you, as future professionals, can position yourselves to serve society effectively in the decades ahead. We'll be covering engineering and sustainable development, the social implications of emerging technologies, policy, law, and regulation in engineering practice, lessons from real-world case studies, successes and failures, the mindset and skills needed for the engineers of tomorrow. 1. Engineering and sustainable development. In recent decades, sustainability has moved from being a nice extra to a core requirement in engineering practice. The idea is simple: meet the needs of the present without compromising the ability of future generations to meet their own needs. 1.1 The triple bottom line. Sustainability is often framed around 3 pillars. Economic sustainability: projects must be financially viable. Environmental sustainability: projects must minimize ecological harm and use resources efficiently. Social sustainability: projects must be fair, inclusive, and beneficial to communities. An engineer designing a new transport system, for example, must consider how much it will cost, how it will affect air quality, and how it will serve different groups of people. 1.2 The role of engineers in achieving the UN Sustainable Development Goals, SDGs. The United Nations has identified 17 SDGs, many of which are directly influenced by engineering, clean water and sanitation, affordable and clean energy, industry and infrastructure, sustainable cities, and climate action, to name a few. Whether you're working on renewable energy systems, low-cost housing, or waste management solutions, you're contributing to these global goals. 1.3 Examples of sustainable engineering practices. Using recycled materials in construction to reduce waste. Designing products for disassembly, so parts can be reused or recycled. Incorporating renewable energy sources into building designs. Developing water purification systems that use minimal energy. 2. The social implications of emerging technologies. Technology is advancing faster than ever, and with it come both opportunities and risks. 2.1 Automation and artificial intelligence. Automation can increase productivity and reduce cost, but it also raises concerns about job displacement. As engineers, it's important to think about how new systems will affect workers and communities, and to design solutions that allow for retraining and adaptation. 2.2 Biotechnology and genetic engineering. From developing drought-resistant crops to medical gene therapies, biotechnology holds great promise. But it also raises ethical questions about safety, consent, and the potential for misuse. 2.3 Information and communication technology, ICT. ICT is transforming how we live and work. Think of smart cities, the Internet of Things, and mobile banking. However, it also creates issues of privacy, data security, and unequal access. Engineers must work with policymakers to ensure that technology benefits everyone, not just a privileged few. 2.4 Climate engineering and geoengineering. Some scientists propose large-scale interventions to slow climate change, such as injecting particles into the atmosphere to reflect sunlight. These ideas are technically fascinating but socially complex. Who decides if and when they are implemented? What if they have unintended side effects? 3. Engineering policy, law, and regulation. Engineers don't work in a vacuum. Their work is shaped by laws, policies, and regulations. 3.1 The role of government. Governments set building codes, environmental standards, labor laws, and safety regulations. Engineers must design and build in compliance with these rules. 3.2 Professional regulation. In many countries, including Nigeria, engineering is a regulated profession. You can't call yourself an engineer or offer engineering services unless you're registered with the appropriate body, such as COREN, Council for the Regulation of Engineering in Nigeria. This protects the public by ensuring that only qualified individuals practice engineering. 3.3 International standards. In our increasingly globalized world, engineers often work on projects that cross borders. This means understanding international standards, such as ISO, International Organization for Standardization, specifications, which help ensure compatibility and safety across countries. 3.4 Public policy influence. Engineers can and should play a role in shaping policy. Technical expertise is invaluable when drafting regulations on infrastructure, energy, environmental protection, and technology. Without engineers' input, laws might be unrealistic or technically unsound. 4. Case studies, engineering successes and failures. Learning from real-world examples helps us understand the human side of engineering decisions. 4.1 Success story, the Okoshi Kaikyo Bridge, Japan. This is the world's longest suspension bridge, designed to withstand earthquakes and typhoons. It demonstrates how engineering innovation, rigorous safety standards, and community needs can align to create infrastructure that is both functional and inspiring. 4.2 Failure example, the Hyatt Regency Walkway collapse, 1981, USA. A design change during construction led to a structural failure that killed over 100 people. The tragedy was traced to poor communication between engineers and contractors, and inadequate review of the revised design. The lesson: always check changes thoroughly and never bypass review procedures. 4.3 Environmental example, the Three Gorges Dam, China. While it generates massive amounts of renewable electricity, it has also displaced millions of people and altered local ecosystems. The project illustrates the need to balance benefits and drawbacks in large-scale engineering. 5. Preparing for the future, skills, mindsets, and responsibilities. The challenges of the 21st century demand more than just technical skills from engineers. 5.1 Lifelong learning. Technology changes fast. The software or materials you learn in school today may be outdated in a decade. Continuous learning is essential. 5.2 Interdisciplinary thinking. Problems like climate change, urban congestion, or food insecurity can't be solved by one field alone. Engineers must work alongside economists, environmental scientists, social workers, and policymakers. 5.3 Global and cultural awareness. In our interconnected world, engineers often work with diverse teams and communities. Understanding cultural differences and global context makes you a more effective professional. 5.4 Resilience and adaptability. Projects can face delays, budget cuts, or sudden shifts in priorities. Successful engineers are those who can adapt without losing sight of their ethical and professional responsibilities. Module 2 Summary. In this module, we've examined the urgent issues shaping engineering practice today, from sustainability and emerging technologies to legal frameworks and lessons from the field. We've also looked at the skills and mindsets needed to meet the challenges ahead. The takeaway is this: engineering is not just about solving technical problems, it's about shaping the world in ways that are sustainable, equitable, and ethical. Your role as an engineer will be both technical and social, and that's what makes the profession so powerful.